Okay, so we have a question here that says find the inverse of the matrix cos theta sin theta 0 negative sin theta cos theta 0. Then we have 0 0 1 there on the third row that we have there. So now, to find the inverse, first things first, we need to get the determinant. Then after we get the determinant, we get the matrix of cofactors. Then after getting the matrix of cofactors, we get the adjoint, which is the transpose of the matrix of cofactors. Then after that, we divide the adjoint by the determinant that we have. Okay, so now, the determinant of this matrix here, we have cos theta. We have cos theta here, sin theta, we have a 0, negative sin theta, cos theta, 0 there, we have a 0, 0, and 1 like this here. So here, we're going to use this third column here, so we not say the signs that we're going to use positive, negative, positive like this here. So here, using that same principle that we have there, we have 0 multiplied by anything here, using here. So 0 multiplied by anything there is just a 0, minus 0 here multiplied by any 2 by 2 matrix that we're going to have is going to be a 0, plus 1. So when we're using 1 here, we close this column and we close this row here. Then we remain with this 2 by 2 matrix that we have there. Okay, so we get that 2 by 2 matrix, we put it here. So cos theta, sin theta, negative sin theta, and cos theta like this here. So then the determinant of a 2 by 2 matrix is just basically the major diagonal minus the minor diagonal. So here we have in the major diagonal cos theta times cos theta, we get cos squared theta, minus negative sin theta times sin theta, we get negative sin squared theta like this. So here, negative times negative, we're going to get a positive value. So meaning that here, our determinant will be equal to cos squared theta plus sin squared theta like this. But then, if we look at this expression that we have here, this is the Pythagorean identity from the trigonometric functions. So cos squared theta plus sin squared theta basically just gives us 1 here. So meaning that our determinant here is simply equal to 1 there. Okay, so now our next focus is to get the matrix of cofactors. So cofactors here. So we need to get a matrix of cofactors, and bear in mind to say that we're going to follow the signs here: positive, negative, positive, negative, positive, negative, positive, negative, and a positive there. So now the matrix of cofactors here is going to be like this. So here on the first part, we not say it's a positive, so we have cos theta here, cos theta 0 0 1, we close there, then here it's going to be negative, there we're going to have negative sin theta, negative sin theta, then we have a 0, we also have a 0 this side and a 1 there, we close, then the next 2 by 2 matrix that we're going to have is going to be positive, following this here that we have. So there we're going to have negative sin theta, and we have our cos theta like this, then a 0 and a 0 there like this. Then we can close this side. Let me just erase that. Okay, so we can close this side. Okay, so now here the sign that we have here is negative. So if we have a negative sign there, the 2 by 2 matrix that we're going to have, then it's just basically sine theta. Sine theta. We have a 0, then we have 0, 1, we close here, then here it's going to be positive there, we have cos theta, like this, then we have a 0, we have another 0 here, we have a 1 there, we close, the next one is going to be negative here, then on that one we have cos theta, sine theta, 0, 0 like this, we close this side, we go to the bottom row there, we know that that's going to be positive there, so we have sine theta, cos theta, we have 0 and a 0 there, we close, this here is going to be negative, then the 2 by 2 matrix that we have there is cos theta, 0, negative sine theta, and a 0 there, we close like this, then the next one is going to be positive here, which is just basically cos theta, cos sine theta, like this, then we have negative sine theta and cos theta this side, we close them like that there. Then we start calculating the determinant of each single 2 by 2 matrix that we have there. So then here, the determinant of this one here is just going to be cos theta. Then the determinant of this matrix here is going to be positive sine theta. We have positive sine theta there. Then the determinant of this matrix that we have here is going to be 0. We can close this side. Then here we're going to have negative sine theta. There. Then here we're going to have cos theta. Like this. Then here we're going to have a 0 there. Then for this one here, we're going to have a 0 there. We have a 0 again there. Then here, for this 2 by 2 matrix here, you notice that you're going to have cos squared theta minus sine squared theta like this. So minus negative sine squared theta. The negative will be positive. You're going to have cos squared theta plus sine squared theta like this. So we not say that this gives us 1, meaning that the determinant of this 2 by 2 matrix here is going to be 1 there. So let me just erase that. Okay, so now that we have found the matrix of cofactors, this one here, so then the next thing that we're going to do is we find the adjoint. So the adjoint is simply the transpose of the matrix of cofactors. So meaning that we're going to transpose this matrix that we have here. The rows become the columns and the columns become the rows. So here, when we do that, we have cos theta, sine theta, and the 0 there. Then we have negative sine theta, and we have cos theta here. Then we have a 0, then 0, 0, 1 like this. So now the inverse of this matrix here. So the inverse is simply equal to 1 over the determinant, then we multiply it by the adjoint of the matrix here. We multiply it by the adjoint of the matrix that we have here. So since our determinant here there is 1, so meaning that the inverse here would just be, okay, so the inverse of a matrix, we know that the inverse simply equal to 1 over the determinant, then we multiply it by the adjoint here, the adjoint of the matrix, so meaning that 1 over 1 is just going to be 1 there, so the inverse here will simply be equal to cos theta negative sine theta here. We have a 0, 0, 1 this side, then we have cos theta here, and we have sine theta, then 0, 0 there. So we can close this side there. So close this side, then this matrix that we have here, this here is the inverse of the matrix that we're looking for there. Okay, let's go to the next